Right. Hello, everyone. Welcome. Thank you for being here. You all look really good today. My name's Dan Roth. I'm a program manager on the ASP.NET team. And in this session, we're going to talk about creating amazing web apps with ASP.NET Core. Specifically, we're going to look at all the new goodies that are in .NET Core 3.0, and we'll even look at some of the new stuff that's coming in .NET Core 3.1. In case you don't know, ASP.NET Core is our cross-platform, open source, and blazingly fast web framework that was custom built for .NET Core. Now, about a month or so ago, we just shipped .NET Core 3.0, which has a whole bunch of great new stuff. We're going to be looking at the new full-stack web development support in .NET Core 3.0 in this session today. But there's a bunch of other stuff that we won't get a chance to talk about, like the new support for desktop apps, WPF and WinForms apps with .NET Core, support for generating native single exe files using the .NET Core SDK, as well as all the great new C#8 features that come with .NET Core 3.0. Now, when I say blazingly fast, I do mean blazingly fast. This is the latest TechEmpower benchmark numbers that compare all of the various web stacks on the planet against each other on a common set of benchmarks. And on the plain text benchmark, ASP.NET Core is comfortably in the top 10. And you can kind of tell that for the stacks that are at this level, they're all sort of bottlenecking now the testing environment. Honestly, ASP.NET Core is really the only framework on this list that you would realistically even use. Unless you really like coding your web apps in C and C++. ASP.NET Core not only is fast, it's also highly productive and fully featured. The speed increases in .NET Core 3.0 are particularly amazing. .NET Core 2.2 was already really, really fast on the TechEmpower benchmarks, from the plain text benchmark all the way up to the JSON benchmarks and the Fortunes one, which involves like database access and those types of things. But look at these numbers for 3.0. Like for throughput, requests per second, we're seeing on the plain text benchmark about 23% increase. For time to first request, that's TTFR. That's like basically how long it takes your app to respond to the first request. Lots of great improvements across the board, 55%, 62%. And then amazing improvements in memory working set in 3.0. 95% less memory usage on the plain text benchmark. Now, how did we do that? Where did these gains come from? Well, reducing allocations was a big part of this. The plain text benchmark is now completely allocation free. There is no allocations done as part of that benchmark other than the initial set. We did a bunch of improvements to the routing system in .NET Core 3.0 through endpoint routing, which is much faster. We have a new serializer in .NET Core 3.0, system text JSON, which accounts for a big chunk of those performance improvements in the JSON benchmarks. For the time to first request, we now have the tiered compilation in the JIT turned on for ASP.NET Core apps, which makes your app start up that much faster. And we also improved the memory reservation defaults for the GC, which accounts for a big chunk of those memory improvements. So pretty nice. Now, .NET Core 3.0, ASP.NET Core in .NET Core 3.0 is all about full stack web development. Now, we've always had a really good story with .NET for building web apps that run on your server, that dynamically generate some HTML. And we have a whole buffet of frameworks that you can pick from in order to do that. MVC, Razor Pages. We have great support for web APIs also on the server. And in fact, in 3.0, we did a bunch of work to further integrate with OpenAPI spec support, including client code generation support. SignalR for building real-time applications where you want to have that real-time connection with the client. Lots of good improvements there that we'll take a look at. And of course, security, super important. ASP.NET Core comes with an identity solution out of the box for managing usernames and passwords, authorization policies, and so forth. In the client, we now have support for building client-side web UI using .NET with a new framework called Blazor. We'll talk more about Blazor in just a bit. But Blazor is a component-based UI framework, so you can now write your UI using reusable components, both in your Blazor apps, could be on the client, right in the browser, or it could be on the server. You can even use them from your existing MVC views and Razor pages. If you're using JavaScript and imagine using JavaScript for the foreseeable future, that's fine too. We've got great support for JavaScript frameworks in ASP.NET Core as well. We've updated our single-page app templates to the latest framework versions and made some improvements there as well. On the back end, we now have a new worker service template, so you can build long-running processes, as well as new support for gRPC, which is a highly efficient binary-based protocol for server-to-server communication. So as you can see, there's now offerings across the stack, full stack web development with ASP.NET Core. Now, how do you get started with ASP.NET Core in .NET Core 3.0? Well, you're going to want to go and download and install the .NET Core 3.0 SDK. You can get that from the .NET website. If you already have the latest version of Visual Studio, the latest stable version, then you've already got .NET Core 3.0 on your machine because it comes packaged with Visual Studio. Go ahead and get your tooling of choice. If you're on Windows, feel free to use Visual Studio. On Mac, you can use Visual Studio for Mac. If you prefer a lighter weight text editor, on Windows, Mac, or Linux, you can use Visual Studio Code. The whole VS family works great with .NET Core. So let's talk a little bit about the client-side UI first. Like I said, .NET has always had a great story for running your code on the server. .NET web apps have always traditionally been server-rendered web applications. The browser sends a request. The server then does some work to dynamically generate some HTML or maybe some JSON, and then sends that back down to the browser to be rendered or to be consumed. But if you wanted to do anything that ran in the browser, well, that meant you had to use one of these guys. You had to use a JavaScript framework. And that's all well and good, but there's sort of an inherent cost in having to bridge these two different development ecosystems. You've got two different languages. You have two different tool chains, two different frameworks, two different ways of just doing things. And for some developers, that's fine. Like having to deal with both is no problem at all. I think of it as being very similar to learning to speak a human language, a natural language. I have a sister-in-law, and she spent some time in the Middle East, and she speaks 5 different Middle Eastern languages. For her to pick up a new language, not a big deal. I know a little bit of another language. I know a little Portuguese. I spent a little time in Brazil. But I can kind of say, hello, my name is Daniel. Where's the bathroom? And that's about it. All the nuances, the idioms, the phrasing that's used in that language, I honestly don't have much of a clue. And I think that same level of investment that you need to really become proficient in a speaking language also applies, at least for most of us, to development languages and ecosystems. And so that's why for a while now we've been working on trying to bring .NET to the browser so you can do full stack web development both in the browser and on the server with .NET. And that's what Blazor is all about. Blazor is a client-side UI framework where you get to write .NET and C# code instead of writing JavaScript. You write reusable web UI components with C# and with Razor syntax. Razor is the templating engine that we use in ASP.NET. It's basically a combination of HTML and C#. You can share your code between the client and the server. Like if you have common domain objects or validation logic, you can use that on both sides of the wire. And if you still need to call into JavaScript, like if you have existing JavaScript libraries that you want to use, or you want to call into some native browser API, there's facilities for doing JavaScript interop as well. To get started with Blazor, I would recommend you go to blazor.net. That will take you to the right page on the .NET website. And honestly, you can get started with Blazor in 5 minutes. Get your first app up and running, no problem. So how does that work? Whoa, hold on. Forever, browsers could only speak one language. They only spoke JavaScript. Well, there's 2 ways that Blazor achieves this. The first we call Blazor Webassembly. If you haven't heard of Webassembly, Webassembly is a bytecode for the web. It's an open standard that's now implemented by all the modern browsers cross-platform. And the idea with Webassembly is that if you can compile your code to Webassembly, this low-level bytecode format, then that code can now run in any browser on any platform at near native speed. That's pretty cool. That's opening the door now for the web ecosystem to now be able to take advantage of the broader set of development tools and languages that are out there. So what we did is we built a .NET runtime in WebAssembly, just like we would build a .NET runtime for any other platform, like Windows, Mac, Linux, IoT devices, phones, watches, TVs, just another .NET. It's just another platform for a .NET runtime to us. This one happens to be implemented in WebAssembly that you can then download with your application. So now you have a core capability of running normal .NET assemblies in the browser, in the normal browser sandbox. On top of that, we built a web UI framework that involves components and composition, parameters, and all the things that you would want to actually build out your UI. And that's what we call Blazor. When the UI events in the browser occur, they get handled by your components. Your components then render whatever they like. Blazor, as a framework, will keep track of what was rendered and compare the newly rendered content with what was rendered previously. It'll calculate a diff, and then it will apply that diff to the live DOM in the browser. That's how it works. So that's Blazor WebAssembly. But there's another mode that Blazor can operate in that we call Blazor Server. In Blazor Server, the idea is we set up a real-time connection between the browser and the server, and we handle all of the UI interactions over that connection. And yes, we use SignalR under the covers for creating that connection. In a Blazor Server app, all of your components run on the server, on .NET Core. They don't run actually in the browser, but there's a little bit of framework code that we put in the browser that sets up the connection back to the server, and it pumps all the UI events to the server and to your components. Your components then handle those events. They do the normal thing that they would do client side. They render, the Blazor framework keeps track of what was rendered before, calculates a diff, but this time that diff gets serialized, sent back down to the browser, and then applied browser side. That's a Blazor Server application. Blazor Server is actually already shipped and available for production today. It's shipped with .NET Core 3.0, and you're welcome to go ahead and deploy it. It's fully supported. Blazor WebAssembly is in preview and is expected to ship in May of next year. Now, how do you choose between these two models? Which one should you use? Well, they're great for different things. Blazor WebAssembly apps are great if you want to build like a PWA, a progressive web app that has offline support. It's great if you really want that zero latency UI experience like you would get with a front-end JavaScript framework like Angular or React. It's also really good if you want to take advantage of static site hosting, because a Blazor WebAssembly app is actually, when you build it, it's just a bunch of static files. You can copy them onto GitHub pages or to Azure Static Site Hosting or wherever you'd like, because you don't actually need to have .NET or any server piece running at all. It's completely client-side. Blazor Server, on the other hand, it has a really nice thin client. The only thing that you need to actually download to the browser is a little piece of JavaScript code that sets up the connection and knows how to apply the diffs and send the UI events to the server. And so as you write more code in a Blazor Server app, your app actually doesn't even grow in size because all the code is actually executing server-side. Your code's running on a full .NET Core runtime, so it gets to take advantage of all the performance and the power of running on the server. It can access your server-side resources, like make calls into your database or wherever you'd like, which can really simplify your architecture. Also, a lot of people really like that with a Blazor Server app, all your code stays on the server. Some .NET devs are a little unfamiliar with the concept that your code's going to get downloaded to the browser in a Blazor WebAssembly app. And they asked me, like, well, does that mean someone can just look at my DLLs and potentially decompile them and see my code? The answer is yes with a Blazor WebAssembly app, just like they could see your JavaScript. But in a Blazor Server app, your code never leaves the server, so that's not even a concern. Of course, also, one is currently supported in production. One is not recommended for production because it's currently in preview. So if you're trying to build something today, our recommendation would, of course, be to use Blazor Server. All right, let's take a look at what Blazor has to offer. I'll hop over to my development machine. So like I said, to get started with .NET Core 3.0, you're going to want to go to .NET. That will take you to this page. You click on the download button, and then down here below, this left-hand side, you're going to want to click on download the .NET Core SDK. If you've already got Visual Studio 16.3 or later, you've already got this, so you're good to go. For Blazor, if you're looking for instructions on how to build your first Blazor app, head over to blazor.net. and then click on the Get Started button. That'll take you to some instructions for how to set up both Blazor Server and Blazor WebAssembly and how to build your first app really, really fast. Let's go ahead and do that. So I've got Visual Studio installed in my machine already. I'm going to create a new project. You can see there's a template right here for building a Blazor app. I'm going to select that. Blazor App 1 sounds like a lovely name. OK, and we'll select Blazor Server. Looks good. And then we'll let Visual Studio create that template and make sure all the packages get restored appropriately. Should just take a second, and there we go. All right, so let's run this and see what this Blazor Server app has to offer. It should have the feel of a single-page app. That's kind of the whole point. You're getting to the functionality of a SPA, but writing C#. OK, so here's our app, and it's a little big because I'm zoomed way in. Let's zoom back out. OK, so I can click around on these tabs, and I can use the forward and back buttons. That's all client-side routing. All that routing is actually happening browser-side. If we look at these tabs, we've got some static content. We have a counter tab where I can click a button and the count goes up. There's no page refresh happening here. There's no post back. This is all happening by updating the browser DOM directly. On this fetch data page, we have a table of weather forecast data that's being rendered out using Razor syntax. So what does the code look like for these guys? Let's go to the project. In the, let's actually show how the app is booted up. So if we look at startup, this is the normal ASP.NET Core startup file. You can see we're adding the server-side Blazor services. And then down below, there we're mapping the Blazor hub. That's the hub that will handle the real-time connection from the browser. And then the root of the app is this underscore host thing. What is that? Well, that is actually just a Razor page, a normal CSHTML file, which handles the initial render of the app. The app actually gets fully rendered with the first request, and that's all done here. So most of this stuff is just HTML. But here you can see there's this HTML helper, render component async, which is rendering the root component of the app, this app class, which is generated from this app.razor file over here. There's not much in this app.razor file. It's just setting up the Blazor router for handling all that client-side routing. Let's go back to host.cshtml. Then at the bottom, there is one framework-provided JavaScript file that you have to use, which is the thing that's going to set up the connection, apply the diffs, and send the UI events to the server. So that's how that works. Where are these? Where does the router route to? Well, each of these .razor files is a component. So this counter.razor file, that's the component for the counter tab. And you can see that it's routable because it has an app page directive. And then we have some normal HTML markup. It's just standard HTML. But then we use Razor syntax to render the value of a C# field right here, the current count. We have a button that has an onClick handler that when clicked will call not a JavaScript method, but a C# method, which is defined below in this @code block. Everything in this @code block will just get added to the generated C# class for this .razor file, for this Razor component. Components are just classes at the end of the day. So that's how that's all working. To prove that that's really happening, I'm going to set a breakpoint. I'm going to F5 this time. I controlled F5 before. I didn't attach to the debugger. And then wait for the browser to come back up, and we'll click. And there, we just hit a breakpoint in our Razor component code from within Visual Studio. All right, now if we stop, let's go back. I think I have to control F5 again. I want to show what's actually happening on the wire real quick. Let's look at F12. And I'll refresh so you can see the network. That's everything that's being downloaded. If we look down at the bottom, yeah, so you can see the total app size is about 422 kilobytes. That's the whole app, including the bootstrap styling and so forth. So that's all you need, and that's all you'll ever need, because all your code's going to be running on the server, so no additional code will need to be downloaded to the client. You will notice that there is this underscore Blazor request, which is a WebSocket request. That's setting up the real-time connection. And in fact, if we click on that, let me go to the counter tab, and I'll clear all the messages that are already there. If I click, you can see there are the frames that are flying across that real-time connection. And you can also see they're pretty small. Like they're on the order of not kilobytes, but bytes. And that's important in order to make sure latency is as low as possible. OK? Now, I did say this is a component-based framework. So each of these Razor files is a component. We can add components to our components in pages. Like, let's say I want to add a counter to the home page. We'll just add a counter right there, and then we'll go back to the browser. Notice that Visual Studio detected that I made an edit to my project. It killed the process, and it's going to restart it again. All I have to do is F5 to refresh. hopefully. And then if I go back to the home page, yeah, so now I have a counter not only on the counter tab, but also on the home page, and they have independent counts. So that's components. All right, how much do we do in time? OK, let's do a little bit of Blazor server development now. The app I wanted to build here was a simple currency converter application. OK, so let's build a component that does currency conversions. So I'm going to add a, let's add a folder, and we'll call this components. This is just my convention. You can put the components wherever you'd like. And now I'm going to add new item. And I'm going to select Razor component. I want a new Razor component for my Blazor app. And let's call this currency converter. .razor. Looks good. OK. So I want to add this to the home page. Let's get rid of the counter. Let's do a currency. So it shows up there in IntelliSense. You get a nice tooling experience with Blazor. It's currently a fully qualified namespace because the using statement for that namespace is not in scope. But that would work. Like I could complete that. And that would be adding my currency converter component to the home page. If I want to have that namespace in scope, I can just add a .NAT using statement right here, Blazor app1.components. And now instead of fully qualified, we can get currency converter just as a normal tag. And it's lighting up purple, which means it's working. OK, let's write some code in our currency converter. What do we want to do here? Well, I'm going to add some state from my component first in this @code block, some fields on the class, essentially. I want to have a list of currencies, so IEnumerable of string, and let's call this currencies. And this will just be an empty string array for now. Like you can imagine, I want to fetch this list from someplace at some point. And then we want a decimal. That will be the from value, the thing that I want to convert to something else. And then we'll have a string, which will be the from currency. And for now, we'll just leave that uninitialized. And now we need a to value. And we'll need a to currency. OK, so we want to convert from to using the currency specified. All right, cool. Let's put a little UI in here. So I want a text box, so an input. And it's going to be of type number. And its min value will be 0 because we're not going to convert negative currency amounts. And let's just close that off. OK, now what I want to do is @bind this input to the from value. OK? What is @bind? Well, that will create a two-way bind between that from value field and the input box, the text box. Whenever that input box gets rendered, its value will be whatever the value is of from value. Whenever the input value changes, then this from value field will get updated with the new value. All right? We also probably want to select. And for the select, we will bind that to the from currency. And you can see I'm getting great IntelliSense here over these values. Super nice C# editing experience. OK, and then for one of those options is probably also going to be selected. So I'm going to put a selected attribute on here. And then here I'm going to use a Razor expression where the value inside the parens here is going to be a Boolean expression. And what is this going to be? It's going to be if the currency that we're currently looping over is the same as the from currency, then selected should be true. That should be the selected currency. All right, cool. All right, so then we're going to say this is equal to some value. It's going to be equal to the from currency. That's just some content. And then we're going to need one other select for the currency we want to convert to. I'm just going to copy the one above, turn this into currencies, and to currency. Does that look good? All right, I want a button so I can actually do the conversion. So I'm going to put a button right here, and we'll call this convert. And let's just start there and see what we got. Do we have at least some UI that has some basic stuff? OK, great. So we've got a text box. We have some drop-downs that don't have anything in them yet because we just have an empty list of currencies. And we got a button that looks like it doesn't do anything either because we didn't wire up an event handler. All right, so let's see. What do we want to do next? Let's initialize some values. How do we initialize things in a Blazor component? Well, there is a component lifecycle events on the component that you can hook. So let's do protected override. I think we just do void on initialize is the event that I'm going to hook. That's basically the initialization point for a component. So and you can do this asynchronously or synchronously. And what do we want to initialize in here? Well, I want to initialize the currencies to something other than an empty list. For now, I'm just going to hard code a string array. So let's do USD and Canadian dollars as well. We'll just have two currencies for simplicity. And then what else? We want the, let's put the initial value for the from currency to be USD, United States dollars. And let's put the to currency to be Canadian dollars. Okay, and then we also want to update the to value to be whatever the correct translation is there. So I'm going to add a little helper function here. It's going to be, let me move this up. What is it? Get rate. Yeah. And yeah, so this is going to actually return a decimal. And what this is going to do, let's say if they are the same. So if the from currency is the same as the to currency, then we're just going to return 1. The rate, the exchange rate will just be 1. If the from currency is equal to US dollars, now obviously I'm just hard coding some exchange rate data. So please don't make any financial decisions based on any of the exchange rate data that you see in this presentation. All right, so I think it's about 1.3-ish. I don't know. So it's, again, just random numbers. Think of it as a random number. Otherwise, we're just going to return, I think about 0.7 is about right. OK. Great. And then so now we have some values that are populated. Let's see if that we're getting better here now. We're getting closer. OK, so now we have some values in our dropdowns. That's cool. The convert button still doesn't do anything, and nothing actually is getting calculated. And I put the wrong thing for the to. I want not from currency. I want a to value. That should be what goes right there. So that should actually be a number, because that's the result of what we want. OK, great. But it's not calculated to anything yet. So we want to initialize that. So I'm going to, and we also want conversion to happen when we click this button. So I'm going to add another method here, convert. And what convert is going to do is it will populate the value of the to value to equal the get, whatever the rate is, times the from value. That's just doing the conversion math right there. And then on initialize, I'm going to call convert just to do the initial initialization for the component. And that, I think, oh, no, one more thing. We need to also have an event handler for the button. So @onClick allows me to specify an event handler for when the button is clicked. And I want to call convert. And you can see it's down there at the bottom. We get IntelliSense. Lovely. Come on, complete. There we go. All right, so save, and that should be done. Let's see if we now have a working currency converter. All right, so yeah, so 1.3, that looks right. Let me make this a little bigger so you can see it. If we change this to US dollars, we expect it to be 1, and it is. If we change this to, like, I don't know, 100, in fact, USD, Canadian dollars, then $130. So it's all working. That's all happening through a client-side UI framework using Blazor. All right, let me switch back to slides. Time is flying. All right, now a lot of people ask me about scale of Blazor server applications, like how well does it scale out? It is a connected model. Like every client that connects to your Blazor app is going to need a persistent connection, and you're using your server resources to run the UI for that client. We do test Blazor under load at scale to see how well it performs. What we do is we take a Blazor app, we put it under load with a bunch of concurrent clients that are active, like actively engaging with the UI, and we monitor the latency to make sure it stays within a reasonable level. When we test with a single virtual CPU machine with 3.5 gigabytes of memory, we're able to sustain 5,000 concurrent clients without any latency issues. If we have a bigger machine, 4 virtual CPUs and 14 gigabytes of memory, we can hit 20,000 concurrent clients with that. These are baseline numbers. Like the UI in this test app is fairly minimalistic. The clients are all just basically clicking on a button. Your scale will, of course, vary based on how much memory you're allocating. It tends to be memory bottlenecked. So memory is really the important factor here. And also your client behavior and your network conditions will, of course, also impact latency. So you'll need to do some planning for your own app. But as a baseline framework level, the scale is looking pretty good. All right, let's look at some of the other features to build the other side of our app. We looked at the front end and the client. What about the back end? So we have gRPC support in ASP.NET Core now, in .NET Core 3.0. It's obviously an RPC framework if you're not familiar with gRPC. What does that G stand for? You know, a lot of people wonder, does that G stand for that company who shall not be named or something? It actually doesn't stand for any particular company name. It stands for gRPC. So gRPC stands for the gRPC Remote Procedure Call Protocol. That's what it is. Now you know. Tell all your friends. It's a really highly efficient protocol for back-end server-to-server communication. And they have a lot of great client-side library support for pretty much any platform you care about, including .NET. And in fact, we've been working with them for on the gRPC support in their libraries to make it really good with ASP.NET Core and with for doing client-side code generation. So things that are new in gRPC, we have a new gRPC service template as well as client code generation. Let me show you that real fast, and then we'll add it to our Blazor app. OK. So I'm going to go ahead and close this and create a new project. To create a gRPC service, I'm just going to search for gRPC, and there's the new gRPC template. Let's go ahead and create that. This is going to be based on ASP.NET Core. That looks like a lovely name for a gRPC service. We'll just do the default template. All right, so what do we got here? Well, if we look in startup and how this is wired up, we're adding the gRPC services. And then down below, we're using endpoint routing to route to a particular gRPC service. What is this gRPC service? Well, that's a class under this services folder. And it has a sayHello method that takes a request with basically a name. You can get the name out of the request and then returns hello, whatever that name is. So it's like hello world for gRPC. It derives from this greeter.greeter base class. Like, where does that come from? Like, I don't see that in the Solution Explorer anywhere. Well, there is this greet.proto file, and that's a protobuf file. That's basically the interface description language, or IDL file, for gRPC services. And at build time, we take that file and turn it into server-side code for you that you can then use to build out your service. So that's actually where that base class is coming from. If I F12 on it, we end up in some like, oh, my eyes are burning, like code-generated code. But that's fine. You're not supposed to edit this code, right? This is build time generated for your convenience. OK. Now we could run this, but it won't do anything useful because we don't have a client. Let's add a client. So I'm going to add a new project. And I'm going to just add a console app. That sounds like a good name for my console app. I have to make one tweak to this because I do have .NET Core 3.1 also installed in my machine, and it, for some reason, picks that up. I'm just going to switch it back to 3.0. OK, now what I want to do with my console app is I'm going to right-click and, let's see, right-click, add service reference. OK? And we get a little UI here for both generating client code for open APIs as well as gRPC. I'm going to click on this. And I'm going to browse from the client project back to the service proto file and just select that proto file. Where is it? Here, greet.proto. That looks good. And yep, I want to generate client-side code. That looks right. So go. This will install some NuGet packages from the open source ecosystem that enables the client-side code generation on build. And the proto file is now linked to my client-side project. Now, I can now consume that. In the interest of time, I'm just going to copy in that code. It's pretty simple. So I'm just going to, nope, just try to copy over my entire Solution Explorer. That would have been interesting. And this is gRPC service 1 instead of test. OK, and we now have all of our using statements. So what's going on here? Well, we set up a channel to our service. We're assuming right now that it's hosted at 5001, which thankfully it is. We create a client using that channel, and then we just call say hello on it, passing in the hello request message and then getting it out again to print it to the screen. So if we now start everything up, and we do need to do a multi-project startup. Let's get everything going so we have both the service running and the client. That looks good, and then we'll F5. OK, so there's the service that just popped up, gRPC service 1. And you see there's the normal ASP.NET Core logging. And then in the background, there's our greeting, hello, greeter client. OK, so that's a simple, that's how you can create a gRPC service and then easily consume it using ASP.NET Core and Visual Studio. Now, that's kind of a toy example. At least it shows you the mechanics of it. What I did, let me open up another project. Where is it? Blazor currency exchange. OK, so I took our Blazor currency converter app, and I added a gRPC service to it. This currency exchange service is a gRPC service. It has its own proto file. I'll show you the proto file real quick so you can see what they look like. So you define a service, and these RPC parts are basically the operations support that service. They take messages and return messages, and you define those messages using protobuf syntax below. So this is a service that can return the exchange rate and also give you a list of currencies. And then I generated a gRPC client into my Blazor application and then just used it. So if we go look for where I think I put the currency converter in the index page directly on this one. But you can see up above, I'm using this @inject keyword to inject an exchange rate service client, a generated gRPC client, into this page. And then it's now populated into this exchange rate client property. The rest of the UI code is the same, but now when I initialize, it's all asynchronous because we're getting the list of available currencies asynchronously. The conversion logic also is asynchronous now because we're using that client to get the exchange rate. And I should be able to just F5 this. And so let's see. So this is the service that's popped up in the background, the gRPC service. And then we have our Blazor server app here. And now we've got a whole bunch of interesting currencies that we can convert between. I don't even know what these things are. Like this is all interesting stuff. But it is, I believe, real data. The service I use for this, just to give credit where credit is due, if I stop the application, I built a little helper library here that just makes HTTP calls to this nice little web API that was provided by by the open source community. So exchangeratesAPI.io. It's an open source project. It's on GitHub. I believe it's from the Python community. And it looks like their data is actually coming from the European Central Bank. So it should be reals. So that's now a full stack web app. We have, let me reload that. I guess I just made a change. Oh, no, I just killed it. Yeah, I just killed the app. That is now a full stack web app with the front-end UI built with Blazor, ASP.NET Core in the middle tier, and then we're using a gRPC service, kind of as like a little mini microservice to handle getting our exchange rate conversion data. Moving on. Now, if you're doing JavaScript, we have good news for you too. We just updated to Angular 8 and React 16. We also did a bunch of work to enable authentication in the Angular and React templates using Identity Server. So you have a full identity and authentication solution now in those templates. I'll show you quickly where you can play with that. So if you go into Visual Studio and do File, New Project, and select, I want to create an ASP.NET Core web app. Web app 1 should be fine. Down here at the bottom is the Angular, React, and React plus Redux templates. You now have an authentication option here to change authentication. And you can click individual user accounts, and that will basically wire up the app to use ASP.NET Core Identity for its authentication concerns. In the Angular app, it'll give you like authorization guards for the routes and client side in the app. It'll set up the app with JOT token authentication and so forth. I'm going to skip doing that primarily because in order to create this template, we would all have to sit and wait for NPM to restore, and life's too short to be doing that. We gotta move on. We don't have time for NPM. Sorry, folks. All right. All right, next is worker services. Worker services are these long-running processes, basically a console app that has extra smarts so it can be started and stopped. They can be hosted in Windows services. They can be hosted with systemd. You get all the niceties of an ASP.NET Core app in a worker service because it's using the same hosting infrastructure. You get logging, you get config, you get DI. They can have endpoints. They don't have to have endpoints. They could just be pulling from a queue. It's basically just a long-running process that you can do whatever you'd like with. And we have a template for that I will show you next. All right, let's go back. No NPM for us. OK, worker service. I'm just going to search in Visual Studio. And there's our worker service template. Great. Let's go ahead and create one. Okay, and this is a pretty simple project. It looks just like a console app. We've got a static void main. And this code down here, if you're familiar with ASP.NET Core apps and how they're hosted, that should look pretty familiar, except we're not setting up a web host here. All we're doing is basically adding this worker type as a hosted service. Like, what is that? Well, a worker, it derives from background service, which just has some simple dispose, start, stop, and exec methods on it. And then, whoop, go back. In the exec function for this particular worker, all it does is kick off a loop and just start logging every second a message. That's all it does. So if we run it in the console, we should just see every second a message popping up saying, yep, I'm doing something, yep, I'm doing something. But the really cool thing is just how easy it is to take this worker service and turn it into like a Windows service. So I'm just going to add a new NuGet package to this service. It's Microsoft, and fortunately it's right there in my auto-completion. That's great. So this Microsoft extensions hosting Windows services. Let's install that. There's a similar package if you're doing systemd, like on Linux. All right, I think that installed. Yep, OK, good. Now if we go back to the worker, not the worker, to the program CS, to the host, and in here, if we say .use Windows service, that should be good. And then I wanted to make one other change, which is I'm going to up the logging level a little bit, because there's some integration with the event viewer that's kind of nice. So that's log critical. All right. Now, I'm going to hop down into the console, because I'm going to do some commands to actually create the service. So let's move into that worker service 1 folder. And let's make sure that it's all restored and building and stuff. .NET Restore is how you just restore the packages for a project. Make sure it's building. What's going on here? It's happened to me before as well. Okay, .NET build. I don't think that's actually, I don't know why it keeps doing that. I'm going to try rebuilding. Maybe there's some bad restore data that kicks around. Yeah, it says rebuild all succeeded in there. So some sort of bug here, but .NET build should be fine. There it goes. OK, I'm going to .NET publish. And I'm going to put this in a worker 1 folder on my machine. OK, great. So now I have a folder. And what I'm going to do is create a Windows service based off of the executable that I just published. So I'm going to copy this particular command just because a couple of command line arguments that I don't want to have to remember. But that worker1 folder has a workerservice1.exe file that was generated in it. That's a new feature in 3.0 where we now generate native executables from the .NET Core SDK. So let's create worker1. Looks like that worked. sc start worker1 is how we can start that worker. It looks like it started. So now if we go into the services viewer in Windows, hopefully we should see down here at the bottom, yeah, there's worker1 and it's running. And in fact, if we go into if I did everything right, if we go into the event viewer and look at the application log, Windows logs, application, we should see all these critical messages being spewed to the screen. There we go, yeah, so critical, critical, and that's our worker service 1. So that's how easy it is to create a worker service from using the new worker template. I need to stop it. Worker1 and delete it so I just don't have that thing running there forever. Otherwise, when I get one of those calls of someone saying, you need to go look at your event log, they'll be like, oh no, there's all these critical messages here. All right, great. Let's go back to the slides. How much time we got? We got like 2 minutes. New SignalR features, client-to-server streaming, and also auto reconnect, and C# async enumerable support. We can see this. We can do it. Stay with me, folks. Don't go. All right, close that. And we're going to open up the streaming clock app. OK, so this streaming clock app is using SignalR. Here's the SignalR hub. And it's returning async enumerable. So that's cool. And it kicks off an async process where it's just doing a loop and writing out the current time every 10 milliseconds. And then on the client, it's just pulling in that data as a stream. Like it just subscribes and just starts pulling in that time data. So if we run this app, we should see that, yeah, so we're just getting this spewed time data down to the client. So that's pretty awesome. If I then if I stop the server and then restart it real quick, and it has to be quick, because we don't have much time, and also because if I don't do it quick, then I have to wait 30 seconds. If I restart it, let's see, this is the timer stopped. So we lost the connection to the server because I stopped the server. But hopefully in like 10 seconds, I think is the first click stop where it should restart. Let's see, does this one work? Oh, no. What happened? What's going on? No? Did you? Maybe it's because now we're really going to have to wait. Let me restart the iOS Express. There it goes. OK, that one's running. This one's going to have to, I think this is going to need like a 30-second standoff now. But trust me. Trust me. It would reconnect. And that's a new feature in SignalR's auto reconnection. I'll just wrap up real quick. That's what's new in 3.0, along with all this other stuff, like Kerberos and certificate authentication. HTTP2 is on by default. We saw a bunch of these things, but there's a bunch more stuff to check out. Check out the release notes. I know everyone likes to take pictures of these things, but the official statement with the full list, I probably missed something, is going to be in the release notes in the ASP.NET Core docs. It's also worth noting that .NET Core 3.1 Preview 2 just came out earlier this week. It is in preparation for a long-term support release. It is planned to be an LTS release for the .NET Core 3.x train. It's mostly bug fixes, but there is a bunch of really cool features in it as well. A lot of Blazor improvements. We have support for component partial classes now. You can pass parameters now into your top-level components. You can prevent default actions for events in your Blazor app or stop event propagation. We have a new component tag helper, so it's easier to use components in your views and pages. The error experience is better. Lots of great stuff to check out there. If you haven't seen it, go check out the blog posts on these features. They're pretty cool. And if you want to learn more about Blazor, like become a Blazor expert, go to the Blazor workshop. It's a full pizza store app that you can work through in like, I don't know, maybe half a day to a day and learn all the ins and outs of the Blazor programming model, aka.ms Blazor workshop. And schedule-wise, 3.1 should ship in November, maybe a few days after, like November 33rd, something like that, I think is the plan. .NET 5 will ship in November of next year, and then we should have an LTS release, a major release every year, and an LTS release on every even numbered release. And like I said, Blazor WebAssembly coming in May of 2020. Had to stick that in there. We're going to squeeze that release in. And that is what I got for you today, folks. Thank you for sticking with me, and I'm happy to stick around to answer any of your questions.